Hey guys, welcome back. We're looking at week 1 of semester 2. Since we won't be having to do as many lessons during the week, since we're through lesson 80 and need to get to lesson 120, we're going to be doing the videos per week instead of per day. So that might be helpful to know for you guys. All right, so today we are looking at lesson 81, and then the next day will be lesson 82. So just 2 lessons for this week. So lesson 81, we're looking at central angles and arcs. So this is dealing with a circle, and then when we break it into sectors, we have what's known as a central angle, and then we can use what we know about angle of a circle. One full rotation we know is 360 degrees. So in this example, if we break it into 4 sections or 4 sectors, our central angles are all 90 degrees, because 90 times 4 is 360. So that's how we're able to figure out what the central angle is. So again, it's going to the center, and then we have obviously radius and radius going to the sides. So those distances would be the same. Okay, if we were to draw a circle and then break it into thirds, and we know that we would then 360 divided by 3, we would make each one 120 degrees, okay, and it would look like that. Now, if there's just 3 sectors and they weren't equally divided, then we would need to know some other information in order to figure out what those central angles were. Okay. Okay, if we're looking at example 2, the court of a playground game is painted on the blacktop. The court is formed by a circle with 2 intersecting diameters, so diameter, and they're intersecting at the center, forming 4 central angles. One of the central angles is 50. And then we can use what we know about vertical angles and intersecting lines. Even though they're within a circle, the same rules still apply. Both acute angles are going to be the same because they're vertical angles, so 50 and 50. These are supplementary, so they have to add up to 180. So 130 plus 50 equals 180. And then we know both obtuse angles have to be the same because they're vertical angles. So we're just given one, but then we can quickly find the other 3. So 50, 50, and then 130 and 130. Because they have to add up to 360, which we know 180, 180, 360. Okay, now an arc is a portion of a circle intercepted by a central angle. So we have the central angle, which is obviously in the center. An arc that forms 1/2 of a circle is a semicircle. So if we ever see that term, we know that's half of a circle. An arc less than a semicircle is a minor arc. An arc greater than the semicircle is a major arc. So for example, minor arc AB from A to B. And we have to determine that because if we just said A to B, well, we could go from A to B this way, or we could go from A to B this way. So we have to indicate minor arc, and we use this little curve symbol above the 2 letters that are connecting, just like with a line or a segment, we do that using a straight line. Obviously, this curve indicates that it is an arc. And then major arc ACB helps us know that we're going from A to C to B. So it kind of helps us, with the direction that we're going. And that's obviously greater than 180 degrees, so that would be our major arc. Okay. And it just goes through some of the abbreviations as we just talked about. And then we can use what we know about circumference of an entire circle to find arcs. So if we know the circumference of something is 10 meters, well, the semicircle, half of that would be 5 meters, or whatever the case may be. We can also use that to find area, area of a circle. And then if it's a semicircle, well, the area of the circle, just half of that would tell us what the area of the semicircle would be. So we're still going to use circumference pi times diameter, and then for area pi r squared, but then we're maybe going to be dividing by 2 or 3 or 4, or whatever the case may be. All right, so we have measure of arc AD. in degrees, what fraction of the circumference is the arc intercepted by ABD? So ABD, that's our central angle. If the radius of the circle is 6 centimeters, that's why we have the 6 right there. And this would also be 6 from B to A. What is the length of the arc in terms of pi? So 60 degrees, 60 divided by 360, this is 1/6 of our circle. Pi times the diameter, well, radius is, or 2 pi r, same thing. So 2 pi r, or pi times the diameter. If radius is 6, diameter is 12, so 12 times pi, or 12 pi. 1/6 of that, or 1/6 times that, we do 1/6 times 12 gives us 2, and we still have pi, so 2 pi centimeters. So it's just one added step to what we already know about circles. We're just going to find whatever fraction the arc or the central angle, whether we're looking at area or circumference of a circle, and then we're going to just, like in this case, we just multiplied by 1/6 in order to calculate this distance. Okay, practice that we'll go over. So that's all we're going to be doing for our first day back. Okay, and then I believe it should be on Thursday. We're going to be looking at this. So again, you can pause and come back to the videos, or you can just watch it all at once, whatever you want. As long as you get the instruction before we cover it in class, that's the most important thing. So lesson 82, we're graphing equations using intercepts. So we have standard form right here, AX plus, okay, this, I think the PDF, for whatever reason, doesn't match up with your book. Should be AX plus BY equals C. So this is standard form of a linear equation. And it should be on your reference sheet, the standard form. Because obviously we're given AX plus BX, we combine like terms, and we have X and Y in our linear. So we've worked with Y equals MX plus B form, our standard notation. Now we have a standard form. And well, why might this be useful? We'll show you, if we're given it in this form, well, we can pretty quickly figure out 2 points. It's linear, so we only need 2 points. We can do 3 or 4 or 5, however many we want. We need at least 2 in order to plot the line. So if you have 2x plus 3y, again, this was a typo, it should be by. So 2x plus 3y in this case equals 12. So how are we going to go through and figure out 2 points? Well, 0 is going to be pretty easy to work with because everything's on the left side of the equation as far as our unknowns, our x and y. Okay, we could manipulate this pretty easily to get it into y equals mx plus b form, graph it, put it into our calculator if we wanted to. That's nothing wrong with that. It's just in standard form that may be creating more work. What we can do that may be even easier than that is we can just plug in 0. So if I plug in 0 for x, as we indicate right here, well, 2 times 0 is 0. So I'm left with 0 plus 3y, or just 3y equals 12. Well, 3 times what number equals 12? Okay, divide both sides by 3 and we get 4. 0, 4. There's 1 point. Now, same standard form, let's put in 0 for y. 3 times 0 is 0, so 2x plus 0, or just 2x equals 12. Divide both sides by 2. 2 times 6 we know equals 12, so x equals 6 in that example. Okay, so the point 0, 4 and 6, 0. So 0, 4, I'm over 0, up 4. 6, 0, I'm over 6, up or down 0. So 6, 0. There's my 2 points. Those are my intercepts, my x and y intercept. Okay, unless the line is horizontal and has no slope, then it would may possibly never cross the x-axis if it was just going through here infinitely in both directions. Or if it's a vertical line, which in that case, it is no longer a... In that example, if we had a line going straight up and down, it wouldn't pass the vertical line test, so it wouldn't even be a function. So we don't have to worry about that right now. So our 2 intercepts, we plot them, we connect the dots. There's our line. Okay, if we have 3x plus 4y equals 24, okay, well, let's make our table. So let's plug in 0 for x. If I put in okay, well, 3 times 0 is just 0, so we get rid of that and divide both sides by 4y equals 6. Okay, so 0, 6. Apologies for handwriting. Then if I want to put in 0 for y to find where y equals 0, that's actually our x-intercept. Where x equals 0, that's our y-intercept. So 3x plus 4y, or 4 times 0 in this case, that's just 0, equals 24. Divide both sides by 3 to get x by itself. This equals 8. So 0, 6, 8, 0. There's my 2 points. We could go in and plot those and then connect the dots, and we would have our linear function. 0, 6, 8, 0. That's how we get to those numbers. They have it broken down right there as well. So in this form, using this method is pretty easy. If it was in y equals mx plus b form, we could still put in 0 for x, slope times 0 plus the y-intercept that would tell us what y is, and then we could go put in 0 for y and manipulate it to get x by itself. But when it's in the standard form, it's a lot easier. We just put in 0. Any number times 0 is just 0. So then we end up with whatever, 3x plus 0 equals 24. Or 0, and for x, we get 0 plus 4y equals 24. So it's a pretty simple step to get our 2 intercepts, which is the 2 points that we need in order to graph a line. We've seen some of these types of problems. I'll show you how we can do this in the calculator again. It needs to be in y equals form for our function, which wouldn't be too difficult to get it in that graph both of them and see where they intercept. But this problem says Martin is thinking of 2 numbers. So we're calling those 2 numbers x and y. He gives these hints. The sum of the numbers is 3. So whatever number plus whatever number equals 3. So there's one hint, but that doesn't give us enough information. If you double the first number, so 2x, and add the second number, the sum is 8. So 2x plus y equals 8. Graph the system of equations to find the 2 numbers. So there's a few different ways you can solve what are known as systems of equations. You can actually use matrices, which is way down the road stuff we haven't even talked about. You'll get into probably in pre-algebra. You can also use the substitution method, which I think we will show a little bit of this year. Solve it in terms of y and then plug it in for y for the other equation, or solve for x and then plug it into the other equation. We can do it that way. Or since we're working with graphing these, okay, let's start with x plus y equals 3. Put in 0 for x. Well, y equals 3. 0 plus y equals 3, so y equals 3. Put in 0 for y, then x equals 3. And over to this one, 0 in for x. We're left with y equals 8. 0 in for y, 2x plus 0, or 2x equals 8. Divide both sides by 2. That's where we get 4. So then we're not done yet, but we're able to graph both of those lines again. I'd recommend using graph paper just so it's accurate. If you're doing it by hand and your scales aren't perfectly drawn, then it may be difficult to tell where exactly they cross. Also, you could graph these into your calculator. Again, got to put it in your y equals mx plus b form in order to do that. But either way, we graph them and make sure we got straight lines and see where they cross. Again, unless they're parallel lines, they are going to cross eventually somewhere. And that point is right there. So the 2 numbers that we're thinking of is 5 and -2. All right, we'll do this practice set together when we get to class. So have this video watched and we'll go from there. Welcome back, and it's going to be a good semester.